Here we are at the DataHour on data engineering tools and techniques. So before we move forward, I just want to give a brief about what data engineering concepts are. So I'm not sure most of you what level of experience do you carry, but let me give you a brief glimpse of this. So data engineering in itself has been a very new technology, wherein you have several tools, and you know, uh, think it this way: what is data? Data is anything which is in raw format to us, right? So anything which is not properly processed is your raw data. So that's what basically data engineering is: playing around with data. Long story short, playing around with data. So moving towards the second slide, we have understanding of tools for data engineering, that is in the table of contents. Next is the agenda, which is quick introduction, scope, tools, examples, conclusion, and then the Q&A. Okay, so that's how we'll be progressing. Little brief about me before we move forward. So Neelam has covered most of those, though. Still, I have strong experience in big data ecosystem, designing and developing pipelines and architectures. Core competencies include big data engineering and analytics, design and development engineering, enterprise data warehousing solutions. Right, an avid reader who is into writing blogs and all of that. That's already been covered. And my hobbies include listening to music, playing guitar. I'm a book nerd. So basically, let's make learning fun. Hmm. And here's my LinkedIn profile. So if you want to catch up post this session, you're most welcome. All right, let's move to the actual slide, the first slide that we have, that is quick introduction to data engineering. So a couple of minutes ago, as I already explained, right, we have this doing something with data to make it meaningful. No jargons, no complex Wikipedia definitions. When you Google what is data engineering, there are thousands of buzzwords which are coming in. That data is this, data is that. You need to do this. You need to you need to be you need to do all you need to follow all these steps in order to convert a manga company or a funk company. So I'm not making it that complex here. I'm just keeping it simple, doing something with data. Let's move forward. So given that you have a brief background about data engineering, that's why we are on to this PPT of tools and techniques. So here we have these data types. Right? So first is structured, second is semi-structured, third is unstructured. Let me give you a glimpse of what these are. Structured, as the name suggests, it's something which is in the form of row and columns, particularly CSV file, Excel file, for example. So an Excel file can be processed with utmost simplicity. That is one data type. Um, Next is your semi-structured. Semi-structured are your XML files, for example, or your log files. So you know, think of it this way: XML file is not that easy to process as a structured streaming file or a structured file is, right? I think that's self-explanatory, that when you say you have an Excel or you have a CSV, it is comprised of rows and columns. You can easily read the data. You can do whatever you want to do your bit over that data. But with semi-structured streaming, you need to put in some regex expressions. Regex stands for regular expression. Sorry for the jargon here. So with semi-structured, you need to process that data, and you need to make it as per your own convenience. So that is where your semi-structured data comes in. Hmm. Next becomes your unstructured data. Unstructured is the data which is the most complex, you can say in one term. So think of it of a video file. So when you play any video or when you play any image, the background of that the background of that contains some codec files, some codec information, some tags, and something which is not very human readable. So that is basically unstructured data. In data engineering, it's our task to handle and cater to each and every kind of data, right? So there are different tools, there are different technologies, there are different, but that's not the scope of this session today. So I give an example already. Need of data engineering. So data of that scale needs to be provided to downstream systems. When we say data of that scale, so you must have heard that Google, people are googling. Google is experiencing thousand or 10,000s or even millions of searches per second, right? So where is all that data going? Facebook, you are liking a status, you are liking a post on Instagram, you're sharing your status, you're sharing a post on Instagram, doing anything, whatever you are doing, it is getting recorded somewhere, you know. So those logs which are getting created over a period of time, that is creating a huge mass of data, right? So it becomes very much important to handle that data. And uh, when you say handle, it becomes more important to, you know, be able to process and utilize the data at the right amount of time. Okay, so therefore a data engineer or the data engineering practices come into play. Hmm. Next we move to the downstream customers, can be data analysts, data scientists, data end customer, etc. So think of it this way. I am uh, I'm saying that you are a data engineer and or a big data analyst or a big data engineer, whatever you may want to call it. So you are that. You're just reading some data, you're processing it, you're loading that data, you're doing something about it. But what is the use of that data ultimately? Who is going to be the end customer? The downstream customers are the end customers who are going to use the data. Hmm? So those are the data analysts. Those can be a data analysts. Data analysts are the people, you know, who are way much into doing the Excel and all of that, and you know, depicting graphs and doing comparisons and all of that. Hmm? Next is the data scientists. You all know, right? You all know what data scientists do. For example, they are involved in training your machine learning models, training, predicting, scoring your machine learning models. So that is the job of a data scientist. End customer can be any customer like you and me. So for example, here I'm working at Paytm, right? So my end customers after my pipeline becomes exactly people like you, me, right? Or the merchants, offline merchants, online merchants, etc., etc. Hmm. So that is the definition of a downstream customers. They all can be our we can create pipelines for them. And when I, why I have written etc. is because not always we are creating something for our downstream customers. It also can happen that we ourselves becomes the customer of the data pipeline that we have written. Okay. Okay, let's move forward. So I hope this is quite evident that byte is the lowest bit of the size of the files, then the KB, MB, GB, TB, PB, exabytes, zettabytes, yottabytes. Normally in big data, we are interested in GB, TB, and very rarely PB. Okay, generally it lands till TB. Okay, so let's move forward. Scope ETL. ETL stands for extraction, transformation, and load. I'm sure pretty much some of you who are from an analytics background or who are from a ETL background, they must be having the differences between ETL and ELT and all of that, right? So that is the ETL, plain and simple extraction, transformation, load. You extract something, you transform that something, and then you load something. Plain. Next is ingestion, processing, and analytics. Quite similar to that, but here instead of loading we have specified analytics. So we are generating dashboards on top of the processing that we have done. Okay, so that's what analytics stands for. We'll read about the analytics tools in subsequent slides. So uh, I'm just skipping this now. Databases. So generally you all must have heard about RDBMSs, the traditional relational database systems. That those are your SQL, MySQL, Postgre, etc. But here there is one more funda, there is one more concept of NoSQL. There is another concept of new SQL databases, but I'll not go that deep. NoSQL databases are generally the databases which are helpful and useful to cater a huge amount of data, to cater to a large volume of data. Okay. Next moves the search engine. So search engines, uh, for the sake of simplicity, you can think of Google as a search engine, right? That is a search engine. But here, the kind of search engines that we are talking about are somewhere different, such as Solar, Elasticsearch, etc. So what is happening in those cases is, uh, think of it this way, just not a very, what is it, not a very apt example, but just to, make yourself quite very familiar or quite very relatable with what search engines actually have in their backend is, uh, suppose you go to Google, you type anything, right? You type what is the weather of, let's say, what is the weather of Delhi in India. Hmm. You search this. Now at the back end, there would be some, okay, so there would be some keywords which are processing on those keywords which we have given, and there would be some search engine which is giving you that information already, that okay, temperature mapped with Delhi, okay, mapped with today, mapped with, let's say, 22 degree. Okay, so that's how it works in the backend, right? Not very apt again, I'm saying, but yeah, quite similar to that example. So we can next move to the DE languages, that is your data engineering languages, stands for your uh, so there are three primarily used languages here. One is your Python, other is your Java, other is your Scala. Java and Python, I'm pretty much sure most of you are aware. Scala is something which is primarily only specific or focused to data engineering folks. So, we have one very major API or very major tool, I would say, Spark. So with that comes your Scala, Java, Python. I know it might be uh, too much information at times, but bear with me. You can refer the recording later, right? So yeah, that's why I want to present with maximum information in the limited time that I have. Okay. Um Also keeping in mind that I am not rushing too fast so that you miss out on things. Hmm. Next, we move to the cloud players and need for cloud in data engineering. I am pretty much sure if you're from a tech background, then you would be having a good familiarity with the cloud players that we have today, primarily AWS, Amazon Web Services, Azure of Microsoft, GCP, Google Cloud Platform of Google. So these are the major cloud players that we have today, and their need becomes okay. So let's take it this way. Hmm. I am assuming you are from maybe a backend, you're a backend engineer, or you are a front end engineer, or any particular stream of engineering and tech. So you must have for sure heard about the servers that we used to have on-prem or on-premise servers. Hmm. So earlier, what used to happen is, for example, I have to do something. I would have to have a server on top of that. Okay, so for that, I need to procure a server into my location. For example, I'm working from Delhi, I'm working from Gurgaon. So I need to have a server in my office location, which used to be a very heavy expense, because I need to have a dedicated infra room, AHU room, if you have heard about it. So I need to have a dedicated room with very good ventilation, and you used to have good servers, racks, and all of that thing. But right now, over a period of time, it became apparent that people are not very much aligned to having an on-prem servers with them. They just quickly want their work done, so they want to move to cloud. You must have heard day in day out that we need to move to cloud, we need to move to cloud, and that is the only example, and that is the only reason why people are much more preferring to move to cloud. So that's that. Next, we move to batch and near real time versus real time. So I think that is pretty much self-explanatory. Batch means in a chunk of load, you are just providing that information in one big group. And real time and near real time, you got that right. Next is the reporting tools. Okay, we'll come on that later. So starting from the traditional stuff, we have this MR, which stands for map reduce. Okay, next is Scoop, then is your Kafka, Spark, Flink, Hive. Till all these categorize somewhere amongst your ETL, or your ingestion, processing, and analytics. So MapReduce used to, I'll not go very deep into this, but it used to have mappers and reducers, and it used to do something related to processing. Scoop is related to the ingestion. Kafka again is related to ingestion. Spark again is related to processing. Flink is related to your real-time processing. Remember, we read here real-time and near real-time. So Spark can have your batch as well as your near real-time. Flink can have a real-time. Kafka can have your near real-time, and Scoop can have your batch. So it's, if someone asks me that what kind of tool we should be using, or it's better that we always make use of a real time system, right? That becomes a very apparent question. But we cannot always go with that sense, because with real time comes the cost of infra expense. So If you are taking everything in memory, if you're taking everything inside memory, the calculation is happening inside the memory itself and it's not spilling out anywhere, then it becomes much more apparent that you go for a instance type, or you go for a server which is of a huge memory capacity. Okay, so that's the expense of going with the real-time systems, even though they are the best. So real-time systems have a different usage. For example, you are, again, I'll take the example of a social media site. So you are double tapping on an Instagram post and you're straight away seeing a like there. That's what real-time system is. Taking the example of a batch is, for example, you do an NEFT and it says that okay, NEFT will be processed in 4 to 5 hours or 6 hours. So that is a batch processing. It runs a batch every 5 hours, and then all the transactions which are in the pipeline, in the which are pending, they get executed. I hope I am pretty much clear here, right? RDBMS, I'll not dive deep into this because I'm pretty much sure everybody is aware. Oracle, MySQL, PostgreSQL, and MySQL Server. Yes, NoSQL. So we have particularly categorized this into 4 categories. First is your document, second is your columnar, third is your key value pair, fourth is your graph DB. On the left hand side, we have examples of these. So we also have other DBs such as MongoDB and CouchDB. They come in the document category. Cassandra and Cassandra, they come in your Cassandra comes in your columnar, right? Your Redis comes. I think this okay. So Redis comes in a key value pair. Take the example of Redis here. Neo4j comes in your graph DB, and so goes for your Arango DB. So Arango DB, Neo4j, they both comes in your graph DB, etc., etc. Next, we move to cloud. So we already discussed about this: AWS, GCP, Azure, 3 major cloud players. Then we have Alibaba Cloud, Oracle Cloud. These are again these Alibaba Cloud. I'm sure you must be knowing about the Chinese Jack Ma, right? So Alibaba Cloud his is his company, and Oracle, you are aware, right? Oracle Cloud. So they have this OCI, which is majorly focused on providing the cloud interfaces for the traditional RDBMS systems or otherwise. They more or less have the same offering. So it's very hard to justify or to take a decision at times. When you need to take a decision there, you need to take into consideration pointers such as what is your team's comfort, right? What is your company uh, primarily interested in, right? For example, your company might have partnered with Microsoft, then it makes no sense to go to AWS, right? Then Azure would be a better choice. So that's that. Next, we move to this DE languages. We talked about this: Python, Java, Scala, right? Python can be used for majority of the things. Majority of the problem statements are catered through Python, especially in the scope of data engineering and your data science and your data analysis. Hmm. If you talk about the Java has always been there. It's always been there, right? Uh, to build robust or scalable systems, you need to go to Java. So that's that. Next is your Scala. Scala, again, I told you a couple of minutes ago, it's particularly or primarily focused on the data engineering side of things. So Scala is more or less functional like your Python and has a mixture of your Java also, but it's very, it very limits the scope that you're working with. Okay. Search engine, Elasticsearch and Solar. These two are most popular search engine being used in this industry. I've written this ELK. So ELK stands for Elasticsearch, Logstash, and Kibana. I'll tell you what these are. So it's a stack, a complete stack, how it's known. Elasticsearch, again, your search engine. Logstash is something which is, uh, there combined, or as a combined utility, it's giving you the power or the ability to ingest data. So that's how and when I say data, primarily logs, I would say. So logs are primarily ingested using Logstash. Next goes the Kibana. Kibana is the reporting. So you can refer, or you can think of it like Power BI, right? Power BI and other reporting tools. We'll be discussing in the subsequent slides. So that's what Kibana is. Plain and simple dashboarding tool. Okay. Now, yeah, so here we are. These are the reporting tools such as your Hyperion, Cognos, Datadog, Grafana, Prometheus, AWS Redshift, GCP BigQuery, Tableau, Power BI, etc. So, uh, you cannot always make use of all of these, or you cannot make use of only one of these. These are intercoupleable, all right, and you also have multiple plugins which are very much helpful to take from one side to the other another. So, for example, in majority of the companies, they have Datadog, Grafana, Prometheus already plugged in. Okay, that is something which is set up by their own stuff. Hmm. So you also have some reporting matrices provided by AWS. So for example, Redshift is your DB. It's one such DB, but it also more prominently goes to the CloudWatch, AWS CloudWatch. So that is where you can see the matrices such as what or how was your cluster, right? What was the cores, or how much were the cores? When we say cores, we mean CPU. So what was the CPU size of the cluster? What was the memory of the cluster when your job was running, and all of that. So all these matrices are very helpful in determining that uh, what is the job that you are running, and what is the infra that it's amounting to. For example, you have taken some what do you call? For example, you have taken some stuff. You have taken some. Uh, you have taken some stuff, yes, right? And now you want to understand more about it, that what needs to be done. So these give you a glimpse that okay, you have a server, for example, of 8 cores, right? When we say 8 cores, we means 8 CPUs. Hmm. So you have a server with 8 CPUs, and you have your memory of 16 GB or 32 GB. Okay, so now it becomes inevitable that you need to have your job running in such a way, or written in such a way, that it only consumes the memory lower to that threshold 32 GB, and lower to the number of cores that is allotted to your server. Okay, because if you go it that way, if your cores exceed or your memory exceeds, then it's a trouble. Your cluster will get fail, and it will get crashed, and ultimately we do not want that. It's a direct impact to the prod customer that we are having. So there are multiple other things that we could have and we would have covered in this session, right? But in the interest of time, because I also wanted to give quite some time to the questions that you guys are having, so let's move there. Okay, I think that's pretty much it. We can take the questions. I'm a data analytics major. Okay, Anjali is saying I'm a data analytics major. However, only on entering my first job, I realized that I need to gain more of mastery in some tools. Okay, and I I, I really think it's so. Could you guide me on the tools that I should learn? Okay, data analytics major. Okay, great, Anjali. So, uh, as I mentioned a couple of minutes ago, uh, for data analytics, for data, uh, so let's understand what data analytics actually is. It's more about doing some analysis on the data that we have provided, or that is already there with you. Okay, so let's say you have BA stands for your business analysts. They and data analysts are quite very similar. So if you have the idea what a BA does, you can very well take that to yourself and take that to a data analyst. So not beating around the bush, I'll come to the point. What next is, so not beating around the bush, I'll come to the point. Uh, Basically, one particular tool that you should be good at is Excel, right? I said that it's Excel. But the problem with Excel is it's only good for limited amount of data. Hmm. And with Excel, you have an option of advanced Excel. You can do the reporting in that, etc., etc. But there comes a time, or in your company, I'm not sure of the volume of the data or the kind of the setup or the layout that your company has, but you can also move to some reporting tools. So the reporting tools that we saw just now, they are way too much good for you, right? you do not need to focus on the ingestion part, you do not need to focus on the processing, you can more focus towards the reporting part. And you can, and it becomes of utmost importance that you also take a deep level of knowledge or understanding of the functional aspects of things. So for example, you are from a telecom background. Okay, so there are some, you know there are some tools, or I would say there are some concepts such as BSS, OSS. BSS stands for a business support systems, operating support systems, and postpaid systems, how they work actually, prepaid systems, how they work actually, your data platform and all of that. So it becomes utmost importance that you have an industry level of understanding there, because you need to do number crunching, right? For example, there comes a scenario that you have some points with you, but you just have a data for them, but you do not know what that data actually means. That is the problem with most of the developers. Okay, be it a backend developer, be it any kind of developer, they just know that yes, I need to process this data, I need to do this with this data, I need to probably write a jQuery, do a jQuery and AngularJS stuff and publish this to my website, right? They know that, but what they don't know, what they are not very much aware about is the functionality of that. So I would also suggest, apart from the things that I've mentioned right now, you should also go to your basics and get your functional things sorted. Okay, so let's move to the next one. I think, I hope I'm pretty much clear. You can again come back. Okay, so we have this Gulzar. Hello, sir. When we use Lambda on AWS. Okay, good question. So what Gulzar is talking here, he is talking of a specific service, which is known as AWS Lambda. Okay, so AWS Lambda is one such service which is mainly used for triggering things. So for example, think of it this way, that I just took an example of an ETL pipeline, right? I just took an example there, ETL. Now uh, now you have something which is there for the processing part, which needs to be processed. So you need to have something to trigger that, right? In that case, you can use Lambda. Let me give the example of this. So for example, you are doing the processing using EMR, right? EMR or Glue, AWS Glue. I'm taking all this services names because if Gulzar is asking about AWS Lambda, then I'm hoping that he is also aware about other services. So if you are using EMR or you are using AWS Glue, which are the processing tools of AWS, then you primarily go to the Lambda, which is helpful in triggering that. Okay. Uh, in Lambda, you can set your trigger point also. For example, you can set up a cron that, okay, after every 1 minute or after every 2 minutes, after every 1 hour or 1 day, or even after, once the file is entered in that particular S3 bucket, my Glue job should get triggered or my EMR job should get triggered. So, to make triggering possible, to write something custom, whatever you want your pipelines to follow. For example, logging, audit monitoring, audit logging is one such thing which can also be done by Lambda. So I hope I was able to answer your question, right? Okay, so next question is Charles. Can you tell a bit about Grafana? So Grafana is, Grafana is nothing much. It's just a simple plain, reporting tool. That's it, right? So you have Prometheus. I just took an example. Prometheus, Datadog, Grafana. It's basically used for what do you call operational level metrics or infra level metrics. You can customize there, and you can see the dashboards. Why it's important to use Grafana at times, not just Grafana, for any reporting tool for that matter, is so there can be two level of metrics, right? First can be your application level of metrics. The second can be your network level of infra level of metric. For example, your job is running, and your job has taken, what do you call, your job has taken uh, 6 hours, let's say, right? Your end-to-end job ran and it's taking 6 hours, but you are pretty much sure that, okay, the amount of data that I have, the volume of data that I have is under 50 GBs or under 10 GB. So what's going wrong? Where am I lacking? Why it's taking so long? It should have been ended in 2 to 3 hours max, right? Max. So what's becoming wrong? So in that case, you have several tactics or several techniques or weapons which comes into play, such as your Spark UI, right? You go to Spark UI, you see the DAGs, you analyze them, you see the logical plan, you see the analyze the physical plan, right? You go there. Otherwise, you go to the cloud matrix. So you go to the cloud matrix, you see that, okay, this is the executor which is getting spawned so much. These are the codes which are getting, which are not being properly utilized. For example, in the EMR, I've used a EMR managed cluster policy, auto scaling policy, and my resources or my cluster is not being scaled up. So, all these matrices you would be able to get via these reporting tools that you have, be it Grafana, be it Prometheus, or anything like that. So these are very much helpful for debugging the infra level matrix also. There is one more thing which is traditionally very popular, which is your heap dump or thread dump or garbage dump, right? So it's helpful in giving you an understanding where exactly is the bottleneck of your job happening. So, but all of that, there is no one thumb rule that, okay, use Grafana and you'll solve all the problems. You need to, gradually make use of each and every component that you have, right? Whatever you can, whatever your DevOps can, whatever your intra network team can, and whatever is the ask, absolutely. You should not be overkilling things. So I think that's pretty much it. How is data mesh going to be in the future? Okay, so these are some new terms such as your data mesh, right? Your data lake, delta lake. I'll give you a brief glimpse of this because this is, I think, a very advanced question for the scope of this session that we have. But okay, so data mesh, it's nothing. It's nothing. It's primarily the collaboration or the intercoupling of your delta lake and your data lake and your data warehousing and all of that, right? So that's that. We can connect offline if you want to have an understanding of more about the data mesh, and I can also explain this with the help of example. So in industry and data space, roles are much mixed, hence it is difficult to market yourself. Currently, I am in a role mix of data analyst engineer. Should I focus on one niche or become full stack data scientists? Okay, so firstly, as I rightly mentioned, I think, right, we have data analyst, we have data engineer, and we have data scientists. So all these three things are, different. You cannot intermingle them. But yes, I get your point totally. In multiple companies today, data engineers are working as data scientists also. Data analysts and data engineering is one and the same thing. So, uh, you know, it always is good to be a jack of all trades, but you need to be a master of one. Okay, I think I've answered here because see, you have been a data analyst and a data engineer in this company, but next company might want you to be a good data engineer. They might have data analysts at their place, so they would not want there. They would not want your efforts to go there. Okay, and same goes for the data scientists. So for example, as a company, you do not have much requirement or scope or the bandwidth to have a data scientists in place, and you as a data engineer, you are just asked to write a plain simple supervised learning model, and you do that. You probably use any of these supervised learning model techniques, your bagging, boosting, or XGBoost, or like GBM, anything like that, and then you just train that model, score that model, predict that model, predict the outcome based on that model. You can do that. That's not a problem. So again, it must be good. It would be good for this company, and you should definitely know what all are the roles and responsibilities of each and every key member of the industry. But you are not expected, and you do not need to deep dive into all of these areas. Okay. Okay. Next, we move to, there are a number of tools that you mentioned here. However, can you please suggest some starting point for a newbie, talking only about the tools, not languages? Always the question. Thank you. Okay. So yeah, well, I would say first you should start with the concepts, the basics of what data engineering is. I'm assuming, Deb, you are from a tech background already, so you are aware about you are familiar about the other tech systems that we have, back end, front end, middleware, and servers, databases, and all of that front. So now you just want to enter into the data stream, data realm. So there, what you can do is you can just have this starting point. As a starting point, you can start with the ETL things, of ETL side of things, extraction, transformation, load. Just start to dig deep. You'll get a hand of all these things which are doing today. For example, in the processing area, you do not have MR used anywhere, right? MapReduce, it's not used anywhere, but it becomes a fundamental backbone of how Apache Spark or how your Flink works. Not Flink, Spark does, right? So, start to know about it, start to read about it. When you switch into Spark, when you'll go into Spark, you'll understand, okay, underlying funda is the MapReduce itself. Then you'll go to Kafka, then you'll understand, okay, in the Kafka we have this real-time thing. Then you'll have a question that, okay, I also read Flink is also real-time and Kafka is also real-time. How are these two different? Then you'll go, okay, Kafka is for the ingestion part of things, and you can also maintain or retain things, but you cannot have the watermarking and all of that stuff which we can have in Flink. So you'll form a comparison there. Start with a notepad, copy and pen, keep on writing stuff whatever you have at hand, and then you'll be able to distinguish among things. So that's pretty much how I think you should be getting started. Reporting tools are very easy, plain and simple. You just watch some YouTube video of some reporting tool, or you just go through the trial version of one of them, and I'll I'm pretty much sure you'll not be able to go into the very deep level of understanding of those tools with this way that I've suggested. But yes, you'll be able to get get a hand or get an understanding of the most part of the tool that you have. Okay, so I think that's pretty much it for this question. What are your thoughts on data warehouses like Snowflake, Databricks? So Snowflake is, where is the question? Okay, so Snowflake is a different thing, I would say. Snowflake is quite different from what we have, and Databricks is a platform, right? So Snowflake, again, it's a company, it's a data warehousing solution company which we have today in the market. Same goes for Databricks. So Databricks is a very prominent or a very I would say good good company who is launching very frequent, who's doing very frequent releases, which are very much aligned with the needs and the requirements of data engineers. For example, the terms that I was referring to a couple of minutes ago, data mesh, right, and your Delta Lake and Delta Warehouse and all of that, right? So those arose because there was some problem with the traditional data lake and your data warehouse. Okay, and Databricks became one of the first companies to solve this problem. So these are the these are the so these are the companies which are not only providing the solutions of typical data warehouses, they are encompassing multiple things in their realm. Okay, here we are talking, if you are talking about the data warehouses, then yes, Delta Lake and Data Lake and all these things would come into play. How will you ETL a stack image of multiple fingerprints on the same spot on an exterior surface? How do you ETL a stack image of multiple fingerprints on the same spot or on an exterior surface? Okay, so I'm pretty much sure. So let's take this example. For example, you're talking about thumb thumb impression, or a biometric system. Let's take an example that way. So when you are taking that, sorry, okay, not sure what happened there. Where's the question? I still remember the question though. Retail, okay, yeah, this one. Okay. So you have this thumb impressions, you have this biometric wherein you are scanning your thumb, and it's getting a data of the fingerprints that are there on your thumb. So it forms a pattern, and at the back end it creates an unstructured data, and then you process that unstructured data and you form an ETL pipeline around it, right? So that's how you can do this. Next is, can you about Kafka as well, if there are any community addition for practice? Yes, so Kafka, okay, so Kafka, we have two Kafkas primarily. One is the Apache Kafka, other is the Confluent Kafka. The Apache Kafka is free of cost. You do not need a server also. You can just use your laptop and you can create a Kafka basic system around it. Okay, so what you can do, you can do a producer and a consumer thing. Okay, so you also asked me, can you also give a brief about Kafka? Okay, so Kafka stands for your pub sub model or your producer consumer thing. Pub sub stands for your publish subscribe. For example, think of it this way: something is being produced or something is being published and something is being consumed. Okay, so that's how your Kafka works basically. Um, let's understand this with the help of an example. For example, you are working for MRF, let's say MRF tires, and you are a data engineer there, and they have a requirement saying that okay, we have these tires and we need to generate the data of the rotational speed of the rotation that the tire does. So what kind of data do you think they would have? They would be having a sensor data, right, where they would have chips, they would have sensors placed in the tires, and it would capture the rotations per minute, the heat getting generated inside the tires, and etc fields. So all that data now needs to be processed, and there is a requirement that okay, for example, I want to discard all those tires which are not able to reach 1,000 degrees. I'm just making that up. 1,000 degrees Celsius, 1,000 degrees Celsius temperature. Okay, so let's say, just for instance, hypothetically, let's just say there are several. There is this company, MRF, which is interested and which is only interested to uh, give a go ahead to all those tires which are able to withstand the temperatures of above 1,000 degrees Celsius. And all the tires which are not able to withstand the temperature, they need to be discarded. So that is a problem statement. So now what you need to do is you need to get the data from those tires. You need to get that. You'll ingest that. You'll process that, and then you'll analyze the data on top of that. When you do the analysis part, then you need to query in such a way that okay, select all from whatever is the table name where temperature tire dot temperature equal or is greater than equal to 1,000, right? 1,000 degrees Celsius, whatever is the value. So in this way you will get the values of or the records of all those records which are having those tires which have withstood the temperature, and those need to be taken care of. So that's how your entire pipeline can look like in this case. And primarily when we talk about Kafka, what it did is it read the data, the sensor data, the pressure, the temperature, and all those stuffs from your tire, and then it ingested into the Spark or in any other stream processing pipeline, right? It gave there and it processed. I hope I was able to explain that, right? So with along with Kafka, there were also some other traditional tools such as RabbitMQ, if you have heard of it. So RabbitMQ or plain MQ. So that's also one other tool. Flume, if you have heard of. So Flume also worked in a similar way, in a similar fashion earlier. So that's what you had here. Okay. Next question is from Manikandan. I am a data analyst, but only working with Excel currently. I have done a data science course recently and did a few machine learning projects. I really want to move to jobs that are majorly focused in Python and SQL. As a non-IT background person, how can I approach a company asking for a job? Okay, so when you've done this, data science and a machine learning project, so I'm pretty much sure that you would be very much comfortable with the modeling techniques and everything around pandas. When you say Python, I'm hoping that you are comfortable around pandas and SQL. Now when you say that you're comfortable around pandas and SQL, then you're already into IT, my friend. So as a non-IT background person, how can you approach a company asking for a job? What you can do is you can simply tell them the projects, the kind of projects that you have built, right? You can also create your own GitHub repo, and you can charter in the projects, the kind of utilities that you have. Okay, so you can create some utility, you can take any real-time problem statement and you can solve that problem. Otherwise you can also go to Kaggle and solve some of their critical problems, and then you can have a leaderboard there. You can score on the leaderboard. So those are the recognitions that you can write in your resume and get selected for the job. Posing that from a real world project perspective, I would say that yes, you already have pretty much of everything that you have to have, and you just need to brush on these skills, and you need to convince them then that yes, the project that you are showing that you worked upon is actually something that you have worked upon, and not something which is given to you by your company or the institute that you have taken your course from. Okay, so you need to have a good understanding there. You just need to be convincible. That's it, as simple as that, right? You do not need to be very much deep dived into the stuff. But if you are in industry, if you are somebody who's just entered into the industry, I think getting a deeper understanding of the kind of the project that you have done and a bit fair idea about Python and SQL should do fine. Okay. Okay. So I'm Nagarjun. Best coding environment for web building with Python Django. Best coding environment. I am hoping that is IDE that you are talking about, right? So IDE is your integrated development environment. For those of you who do not know, I personally prefer PyCharm, to be very honest, right? Though you have several other IDEs, you have several other tools. You can use Jupyter. Jupyter, it's good. Spider. Some people also use Spider. PyCharm. Even some people use IntelliJ. So it's pretty much everything is the same. You just should know that what is the thing that you're trying to create, and you should be good there. Right? That's not a very big ask. Okay, what is the best tool for orchestrating and scheduling? Oh, good question. I have not covered any orchestrating or scheduling point here. So I'll take a moment to explain this. How are real-time jobs different from batch jobs in terms of tools used? Okay. Okay, I'll take the first question first. Orchestrating and scheduling batch jobs. So what do you mean by orchestrating for the others? Orchestrating means tools which are helpful in giving the entire control to themselves of the job that is running. For example, one job one pipeline which is comprising of three tasks or three sub jobs. First is your feature layer, second is your pre-computation layer, next is your computation layer. For example, you have this three. Now you want somebody to tell them that okay, firstly you need to run the feature layer, then you need to run the pre-computation, and then you need to run the computation layer. Okay, so in that sense you have these orchestrating tools. Okay, now if you talk about banks, traditional banks, you would easily see tools such as your Autosys. Okay, so Autosys is one such tool which is used magnificently in banks. Otherwise, you also have some other tools such as Uzi. Uzi is one such tool which was popular quite till quite a couple of years ago. Now, these days, you must have definitely heard of Luigi, Airflow. Okay, so Airflow is, I think, the most popular tool if you talk about today around the orchestrating and scheduling jobs. Airflow can handle both batch jobs and your real-time jobs. One more point, when you talk about the orchestrating stuff, you do not necessarily means a sequential orchestrating of jobs. You can also, uh, jumble up the jobs the way you like. So for example, if there comes a requirement where my client wants me to run computation job first and then go to the feature computation part, feature job. So in that case, what I'll do is I'll just tell my Airflow that okay, you need to take this DAG. You need to create a DAG in such a way. Airflow works with the concepts of DAGs or directed acyclic graphs. Okay, so you need to just tell your Airflow that okay, you need to pick this task first, right? You pick this task and then you go to the second task and then you take the feature computation. Or you can even invert these sequential order, or you can also run your jobs in parallel. So for example, there is, for instance, one more job, post computation, for example. Now you want your pre computation and post computation to run in parallel, for instance. All right, so now what you need to do, you need to go to your feature computation, then you need to run your computation, and then you can give your task inside your task groups. You can give your pre-computation and your post-computation all along in parallel. So long story short, it's manageable. Everything is manageable. Same goes for autosys. There could be one more requirements that, for example, there is one job which needs to only get started once the previous job gets completed. Okay, so in those cases, you can you can make the first job dependable on the second job, right? You can make the first job the child job of a parent job. Okay, so all these intermingling among the jobs, that's what an orchestration tool is. When you say scheduling is your typical cron scheduling. So it, at the back end it works the same way a cron does, right? So you set up a something in cron, right? Star 2 star 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 star, that means that run at this particular time. So in the same way you can schedule. It's giving a fancy UI, nothing more than that. That's what scheduling is. How are real-time jobs different from batch jobs in terms of tools used? So uh, we just explained a couple of minutes ago that real-time jobs are different, and there are some tools which are same for both batch jobs and your real-time jobs. So for example, your Spark. Let's take the example of Spark. It is common in both. Okay, so if you deep dive into Spark, you have some components of Spark, such as Spark Core, Spark SQL, Spark Streaming, Spark Graph, Spark R. Okay, so these all are these various, what do you call, various parts of your Spark API. Right now, if you talk about Spark SQL or Spark Core, those are particularly for a batch time. But if you talk about Spark Streaming, that is related to your near real time. Okay, so that's that. Otherwise, you have Kafka, which is for your real time. Generally, it can also serve as batch, not a problem there, but it has a retention period of some time, so you need to set that accordingly. Scoop, it is for your batch, right, which we understood a couple of minutes ago, which we studied a couple of minutes ago. You have Flink, which is your real time job, real time tool. So that is there, and etc. etc. You can also, needless to say, you can always write a custom wrapper on top of the jobs that you have, and you can do the stuff the way you like. So that's that. With real time jobs, there comes some more challenges, such as there is some packet of data which is not sent at the particular point of time, and that needs to be catered. For example, you are expecting at, let's say, 2 o'clock, some packet should arrive, but it's arriving at 2:10. Now, should you be handling that packet or should you be discarding that packet? So those kind of configuration needs to be done in the real time jobs. But for the batch jobs, those are not the problem. If you have a batch job which is running at hourly at 4 hours, within 4 hours, after every 4 hours, then all the packets which are arriving till till 5:59, they all everything would be catered. So that's pretty much it for the batch jobs and for the real time jobs. Okay, so uh, next question. Should I? It's also another 8 minutes. Just thank you so much. However, my eventual goal is to be data scientist. How would a transition from analytics to data science be? Would a transition from analytics to data science be? So nothing much. They are quite very similar and different. Right? You can start to learn your data science tools and techniques. Right? For example, we just talked about the supervised, unsupervised, and deep learning part of it. Right? So those are the things you should look forward to. And just one point, kind of a disclaimer I want to give here, that many a time it's been said, or it's been showcased that data science, it's a buzz thing to go for. Definitely it is, but not everything ends at the data science layer of things. If you are a good data analyst, you're equally good as an average data scientist. Data scientists right now are being in bulk, right? So always try to be in the place where you have a good demand and the supply is less. I think that's what my concluding note would be. Neelam, do we have things for more? Yeah, please. You want to say something?
No, you can take a few more questions, then we'll wrap up.
Okay, okay, okay. How important is the foundational knowledge in statistics and mathematics? I want to do a course for the required mathematics to be a data professional. Would you suggest any? Okay, to be a data professional. Professional is a very ambiguous word here. So, for example, if you are talking about the data scientist, then you need to, think of it differently. And if you are working or if you are trying to be a data engineer, then you need to think of it differently. And same goes for a data analyst. So definitely some basic level of understanding for statistics and mathematics is needed, but that is not the say all or start all or end all of things. You should, apart from these, you should also have the understanding of how to solve real world problems. Actually, that is something which is very, very important. Not, learning about the concepts or not learning about the kind of tools that are being used primarily in data science or data analysis, but you should also be knowing how or what is to be chosen if one such problem arises. So that becomes, of utmost importance. Next is, could you please tell us something about Apache NiFi and Airflow? So I think we already talked about Airflow here, right? Apache NiFi is quite similar to this, where it is talking about the ingestion part of things. Okay, so NiFi is your UI based tool, which is just making your life easier. It's just simplifying things. So, for example, you can have multiple blocks. Right? You can have multiple blocks, and you can just connect them, first block to another, first block to another. So you do not need to go to the shell every time and do the hard stuff there. You can simply handle and manage all of that from the UI itself. So that's how your NiFi is. NiFi is coming into play. Actually, what is the ideal job of data ETL look like, and which step we have to follow to write that? What is ideal job of ETL look like? Okay, okay. What kind? So there are several ETL tools also. Okay, for example, one is Data Stage, Informatica. So these are some ETL tools. I'm pretty much sure if you need more understanding about how these work, you can quickly Google these. uh, Data Stage, Informatica. I'm repeating them. So these are the tools which give you an ERP kind of an environment where you can have all the extractions, transformations, and loads. Okay. Apart from that, you've asked me what uh, where we have to step to write that. So to write those kind of tools, or I mean to write those kind of frameworks or wrappers, you need to log into your server. You need to do a typical SSH, log into a server, and do the hard coding part, or the coding part. So that's that. Hmm. Next, we move to importance of certifications like AWS, GCP, Azure, Snowflake. So yes, definitely certifications are of utmost importance. Uh, Basically, think of it this way: if you have sent your resume to X company and there is somebody else who is a certified AWS practitioner or a solution associate or an architect, and he has sent his resume, and if there is only one vacancy which is there for that particular role, then they would definitely consider the person who has a certification. So certifications are, yes, they are important, but if you only have the certification at hand and you do not have any practical exposure of things, then certifications won't do much to you. So you should be having an understanding of the project that you have worked upon on those tools and technologies on these cloud platforms that we are seeing right now. And you should have a bit fair idea about the other services also, not just the ones that you have used. And apart from that, you can definitely go for the certification. That's only going to add to your resume. All right, thank you.